In this video, we're going to learn how to conduct a hypothesis test for the difference of two means. We use hypothesis testing for the difference of two means when we have dependent samples. Given the following information, we have two dependent groups. When you're working in hypothesis testing for the difference of two means, sometimes you have to decide whether or not you can perform this type of hypothesis test based on whether or not your groups are independent or dependent. We conduct hypothesis testing for the difference of two means for dependent groups, and often you're looking for a clue that indicates we have one group to which two treatments are being applied, such as a before and after treatment. For this particular problem, we won't write out a specific scenario, but instead we'll look at a before and after, and we'll let this be about anything. It doesn't really matter, except to say that we'll have a group for which we'll apply a treatment at the beginning, our before group, and then after a period of time, a second treatment, which represents after. We will use an alpha level of 5%, and that is also called our level of significance. Looking at our null and alternate hypotheses, we see that our null hypothesis, HO, states that the mean difference is equal to 0. The null hypothesis always contains a statement of equality or no effect, and so in this case, since we say our mean difference is equal to 0, we must say that HA, our alternate hypothesis, is not equal to 0, which indicates that we're conducting a two-tailed hypothesis test. Since we're conducting a two-tailed hypothesis test and our significance level alpha is 5%, because the total area under the bell curve is equal to 1, our 5% alpha will be split into the two tails, so we put 2.5% in each. We'll represent those amounts in decimal form. We split our alpha of 0.05 into 2 and put half in each tail. And also can recognize that this corresponds to a 95% level of confidence. Next, we'll establish our critical values of t, and we are using a t-distribution because we have a sample size less than 30. That is, we have 12 pairwise differences, and we have no population standard deviation given. So to find the critical values of t, we can use a t-table with degrees of freedom of 11, since our degrees of freedom is equal to n, our sample size, minus 1. Our sample size is 12 minus 1, which equals 11. So you can use your t-table, or you can use the inverse t function on your graphing calculator. The inverse t function does not appear on the TI-83 calculators, but it does appear in the TI-84 Silver Edition. To use it, you'll go to Second, Distribution, Option 4, which is inverse t, our area will be 0.025 because we'll start by looking for the critical value of t the left endpoint of our interval, and then we'll put in our degrees of freedom, which is 11. This gives us a critical value in the lower bound of negative 2.20, and our critical value in the upper bound is positive 2.20. Next, we'll use our graphing calculator to enter our data and set up a hypothesis test. We'll begin by entering our before values into L1, our list 1 in our calculator, and then entering our after values into list 2, or L2. To do this, we'll press the Stat button, select option 1 for edit, put your before values into L1, and your after in L2. And I'll show you a screenshot of what this should look like. After you enter your data, you'll want to check both lists to make sure everything's been entered accurately. Now that you've entered data into L1 and L2, you'll need to enter the pairwise differences into L3, and it's from L3 that we'll conduct our t-test. Now, it's not necessary to enter those differences by hand, although you can if you like. For this example, we'll be taking L1 minus L2. You can do this manually and enter each value into L3, or you can highlight L3 using your arrows, and then press second L1 minus second L2, press enter, and L3 will automatically be populated with those differences. So here's a screenshot of what it looks like when L3 is highlighted. And this is what it looks like after you've entered second L1 minus second L2. Now if we like, we can look at those summary statistics for L3 if we wish to identify the mean and standard deviation, D bar and S of D bar, our mean of the differences, and our standard deviation of the differences. We'll do this by hitting our Stat button, and then we'll arrow right to Calc, and we'll select option 1 variable statistics, after you press enter, you'll be able to assign the list that you want to generate your statistics from. And so we'll choose second L3, and it should look like this, where X bar is D bar, the mean of our pairwise differences, and SX is the standard deviation of D. Now to perform our hypothesis test, we'll press the Stat button, arrow right to Tests, And because we're using a t distribution, we'll go to option 2, which is the t-test. At the top, you'll highlight Data and press Enter. Next, you'll enter your null hypothesis, mu sub 0, which, for pairwise differences, we use 0. So mu null, we'll enter 0. For the list, we'll select L3 by pressing second L3. And then below that, you'll see mu, and you'll have options to choose a two-tailed, left-tailed, or right-tailed test. We'll select two-tailed, and from here we will calculate our result. So let me go to another screen to show you what that screenshot should look like. And once we press Calculate, we'll achieve the following results. Here are the results of our t-test. Our standardized test statistic is 1.33. Our p-value is 0.20959, and so on. 0.21. And because our p-value is greater than our alpha, our p-value being 0.21, and if you recall, our alpha, or significance level, is 0.05, because p-value is greater than alpha, we must fail to reject the null hypothesis. Since our claim resided in the alternate hypothesis, and we fail to reject the null hypothesis, the sample evidence do not support the claim, that our mean difference is not equal to 0. In other words, it appears as though there is no significant difference between the two groups. So this concludes our example of conducting a hypothesis test on two dependent groups. I hope that you found it helpful, and we'll see you next time.